In this video, we're going to be going through and filling in a foldable. You should have gotten the paper in class for your foldable, so we're just going to fold it and make flaps. So you're going to fold it almost in half, but not quite in half. We want to leave a little room to put our title of transformations off to the side, and then you're going to fold the rest of it in half. All right, when you fold it in half, you're going to take the smaller side and cut it into 4 flaps. So you have 3 cuts. So if it were fully open, you would have something that looks like this, but much better. Alright, and then your title goes down the side here. So whenever we start filling in for our information, we'll put stuff for translations in the top quarter of the page. Alright, then we'll put stuff for rotations or reflections here. And then the third quarter, we'll put rotation information. And then this bottom part, we'll put our dilation. Alright, so we're writing on the same section or the same side that has our title on it. So we're writing on the side that is not cut. Alright, so if your foldable is ready to go, continue. If not, pause for a few minutes until you get ready, and then we'll start filling in the foldable. So the first thing we're going to talk about is translations. Right, we did a lot with translations, and we had several different ways of writing our translations. One way is just to write it out in words. So we could just say that we're going to translate a coordinate point or a figure. We can say we're going to translate right A units and up B units. Alright, that's just saying it in words. Or we could also write it as a coordinate and say x, y maps onto x plus A and y plus b. Remember, those would be negative if you were going left or down. And then we could also write it as a vector. If we write it as a vector, oh, looks like my pen froze. If we write it as a vector, it would just be our less than sign with A, comma, B. Alright, so we have all those different ways of writing it, and I apologize for the writing that's about to ensue. It looks like my writing thing just died on me, so it's going to be me and the mouse. Alright, so if we think about a translation, we talked about it being an isometry, right? Because certain properties are preserved, looks the exact same, the preimage and the image. So it is an isometry. Alright, and we talk about those properties that are preserved. We have the ABCD, our angle measure, betweenness, collinearity, and our distance, and then we also added in orientation. All of those properties are preserved after we translate a point or a figure. Right, we talked about compositions of transformations, and we would represent our translation with a capital T. And remember, wherever we're translating it would be somewhere down here in the bottom. So you probably have like a vector form, and it would be written as a subscript. Alright, next we have our reflections. We have horizontal and vertical reflections, right? And we have some rules. So if we reflect over the x-axis, right, our coordinate x, y will map onto x negative y. Right? Remember, anytime we're going over a horizontal line, our x value stays the same. Right? We reflect over the y-axis. Right? Now we're reflecting over a vertical line, so our y value stays the same, and our x becomes the opposite sign. Right? We also did y equals x, which is a line. Reflect over the line y equals x, and in that case, our xy just switch, and it becomes yx. And we also reflected over y equals negative x, where they flip and become opposite signs. So we end up with negative y, negative x. Alright, a reflection is also an isometry. Alright, and our properties are still preserved. Angle measure, betweenness, collinearity, and distance. Alright, and then our orientation is reversed. The orientation does not stay the same, it is reversed. It's still the same, it's similar, it's very close. It's just reversed, it's backwards. Alright, and whenever we talk about compositions with reflections, we represent reflections with a lowercase r. And our subscript would be x-axis or y equals 2 or whatever line we're reflecting over. Alright, then we talked about rotations. Now remember, rotations are always counterclockwise unless stated otherwise. So if it just says rotate 90 degrees, we're going counterclockwise. Alright, just like with reflections, we have rules for rotations. So if we're rotating 90 degrees counterclockwise, xy will map onto negative y x. 180 degrees counterclockwise, xy would map onto negative x, negative y, and 270 degrees counterclockwise, xy maps onto y, negative x. Alright, now remember, you might be asked to find something or to rotate a figure clockwise. Well, we don't have specific rules for those because we have these rules. So if you want to remember, 90 degrees counterclockwise is the same as 270 degrees clockwise. 180 degrees is the same both ways. So it's the same as 180 degrees clockwise. And 270 degrees counterclockwise is the same as 90 degrees clockwise. Alright, and then if we rotate 360 degrees, we're back where we started. So when we look at rotations, alright, it's also an isometry. Alright, we have our angle measure, betweenness, collinearity, and distance preserved, as well as our orientation. So all of our properties are preserved with rotations. When we talk about compositions, we represent rotations with a capital R, and our degree of rotation would be our subscript down at the bottom. Alright, last one is dilations. Alright, with dilations, we talk about xy mapping onto kx, ky, where k is our scale factor. And I apologize for this terrible handwriting. Alright, so if k is greater than 1, it's an enlargement. If k is between 0 and 1, it's a reduction. So it's getting smaller. Alright, dilation does not make an isometry. It is not an isometry because we are changing the size. Alright, but the things that do stay the same, our orientation stays the same. And our angle measure. The angle measure stays the same even when our shapes get bigger or smaller. Right? One thing that's important to remember is that all of our points of our pre-image and our image are collinear, which means they're on the same line. So they're collinear with the center of dilation. So we talked about our center of dilation is the origin. And so if we had A and A prime, and we drew a line from the origin through A and A prime, they'd all be on that same line. And the last thing we want to remember with dilations is if we're asked to find our scale factor. Right? Sometimes you'll be asked to find, it'll give you a scale factor in your pre-image and you have to find the image, but sometimes you might have to find the scale factor given the pre-image and image. So remember to find K, remember KIP, K-I-P. Alright, K equals I over P, which is the image over the pre-image. And this is talking about the distance the image and pre-image are from your center of dilation. Alright, so that's how you find your scale factor. Okay, one more thing. I want you to turn your foldable over to the back and just write down a couple of notes, a couple of things that we've determined over the last couple of days. So if we reflect, oh, terrible R, if we reflect over parallel lines, alright, reflecting over parallel lines is the same as translating your figure twice the distance between your lines. So if we reflect over parallel lines, it's the same as translating twice the distance that's between our parallel lines. Alright? We also reflected over intersecting lines. Alright, so when we reflect over intersecting lines, it's the same as rotating twice the angle between those lines. Alright, so if we rotate between or over the x-axis and the y-axis, or excuse me, reflect over the x-axis and y-axis, they make a 90-degree angle, so it's the same as rotating 180 degrees. Alright, and then our last little note for the back is that the composition of isometries is an isometry. Alright, sorry about this I don't know what happened there, it got a little crazy. Alright, but the composition of isometries is an isometry. So if we do a composition of translation, reflection, and rotation, it's going to end up as an isometry. Alright, and that is all for your foldable.